Now that you know how to measure and classify angles, we're going to explore some angle pairs, because angles frequently come in these helpful pairs. The first angle pair is adjacent angles. These are two coplanar angles with a common vertex, one common side, and no common interior points. So you can see in our figure that angle MRN and angle NRP are coplanar. They're on the same plane. They have a common vertex at point R here, and they have a common side. If you look at the interior of the two angles, they do not overlap. So we can say that angle MRN and angle NRP are adjacent angles. And our next angle pair is a pair of vertical angles. And these are two angles whose sides are opposite rays. So you'll notice in our figure that ray JK and ray JW are opposite rays. They form a straight line. And also ray JL and ray JU are opposite rays. They form a straight line. That means that angle LJK, this angle here, and angle WJU, that would be this angle here on the bottom, are vertical angles. And likewise, you could also say that angle LJW and angle KJU are vertical angles. Every year, I find most of my students know these next two angle pairs, this first one being complementary angles. These are two angles whose measures total to 90 degrees. So you'll see in our figure that angle E is 30 degrees and angle S is 60 degrees. So the measure of angle S plus the measure of angle E is equal to 90 degrees. That makes the two angles complementary. Also, notice over here that we have a right angle. That red box means that angle YVJ is a right angle. And because of that, we know that angle YVX and angle XVJ are complementary angles. And that's simply because they form a right angle, their measures have to total to 90 degrees. And one more really quick angle pair that most students already know are supplementary angles. These are two angles whose measures total out to 180 degrees. So you'll notice that angle M is 72 degrees, and angle S is 108 degrees. So angle M and angle S are supplements. Also, take a look at angle RCB. That is a straight angle, and that means that it equals 180 degrees. Therefore, angle RCT and angle TCB, these two angles here, their measures have to total 180 degrees by the angle addition postulate. Therefore, we know that angle RTC and angle TCB are also supplements. Okay, let's try this really quick. Use the figure to determine if each statement is true and explain. Angle BFD and angle CFD are adjacent angles. Well, there are four attributes to adjacent angles. Let's see if they meet them. First, are they coplanar? Yes, they are in the same plane. Two, do they have a common vertex? Point F is a common vertex. Three, do they have a common side? Both of them contain ray FD, so they do have a common side. And then four, do they have no interior points in common? The interior of angle BFD is this whole angle here. And the interior of CFD is this portion of the angle. So you will notice that they do overlap. So no, this is not true because they have overlapping interior points. Moving on, are angle AFB and angle EFD vertical angles? Well, angle AFB is this angle here, and angle EFD is this angle here. To be vertical angles, they must be two angles, and their sides must be opposite rays. So if you look at ray FA and ray FD, they are indeed opposite rays. However, ray FB and ray FE do not form a straight line, so therefore they are not opposite rays. So therefore, this is also not true, because ray FB and ray FE are not opposite rays. And finally, are angle AFE and angle BFC complementary angles? Well, angle AFE is 62 degrees, and angle BFC is 28 degrees. And 62 degrees plus 28 degrees is 90 degrees. So yes, this is true because their angle measures total 90 degrees.